Okay, the next topic is going to be percent composition. Remember, when we talk about percent, how do you calculate it? It's the part divided by the whole times 100%. And we've done this when we talked about roses. Now, we also went through and talked about mass percent, where the part is in grams and the whole is in grams. So my units will cancel out times 100%. But the only reason we say mass percent is just so you know we're looking at the mass of subjects of the parts and the wholes. Well, what about percent composition? Well, when we're looking at our compounds in particular, we're interested in knowing how much each element makes up in that compound. So we're going to be using the mass of the elements in the compound that we're interested in divided by the total mass of that compound times 100%. And what we'll do is for these masses, we're going to assume 1 mole of substance. So it's going to be the molar mass of the compound, the molar masses of elements in the compound. So let's do some examples. So if you recall, let's say if I had $50 roses, and let's say 10 are white roses. Okay, then if I said what percent of the roses are white, you would just follow the formula. You would say, okay, so the percent would be equal to 10 of the white roses divided by 50 roses total times 100%. And then you would say something like, oh, that's going to be 20%. Okay, are white. So that's just how, again, we calculate percent or use percent. Now what happens if we look at mass percent? So I say 25 grams of an iron ore contains 6.2 grams of iron. What is the mass percent of iron? And if we follow that formula that we had in the previous slide, percent is going to be equal to part, which is the 6.2 grams of iron, divided by the whole. In this case, it's going to be the iron ore. So that's divided by the 25 grams, okay, and times 100%. So in this case, 6.2 divided by 25, okay, I get something like 24.8%, and since it's two significant figures, we'll round it up, so it'll be 25% iron. Okay, so that's how we handle basically a mass percent. Again, part divided by whole. So what about percent composition? So let's start off with water. So what is Z? of each element in water. So to do this, what we're going to need is we're going to need the molar masses of hydrogen, which is 1.008 grams per mole, of oxygen, and I'm going to just do the 15.9994 grams per mole, and then of water, which should be 18.015 grams per mole. Okay, so we know how to calculate the molar mass of compounds. So then to do the percent composition, so for hydrogen, what we have is the percent is going to be equal to the mass of the hydrogen. So how many do I have though? I have 2 of them. So I have to remember to multiply the molar mass of hydrogen by 2, because I have 2 hydrogens, and then divide it by the whole, which in this case is just 1 molecule of water. So that's 18.15, and then multiply it by 100%. When we do this, this is 5 sig figs, that's 4 sig figs, so we're going to do the 4 significant figures. 2 times 1.008 divided by the 18.015. And we get basically 11.19% hydrogen in water. Alright, and we do the same thing with oxygen, but with oxygen I only have 1. So now, with oxygen, the percent is going to be equal to the 15.9994 grams per mole, because we only have 1. You don't have to multiply it by anything. Divided again by the 18.015 grams per mole. Okay, times 100%, and that's going to be equal to and this is 5 significant figures, and this is 6, so we're going to go with 5, and that's 88.812% oxygen in water. Okay, so that's all we're doing. Again, we're doing the part divided by the whole times 100%, and now when we're doing the percent composition in compounds, the whole is looking at the molar masses. So 1 mole of compound, and then we're going to look at the percent of that. So let's do one more example. Let's try. What is the percent composition of each element in copper to sulfate? Okay, so before we can solve it, part divided by whole, what do we need? So 1, we need to know our formula. Then 2, we need the molar mass, masses. And then 3, we can calculate the percents. Okay, so what is the formula of copper 2 sulfate? Well, copper 2 ion, remember this is a charge, looks like this. sulfate, you'll have to consult your polyatomic ion table if you haven't memorized it. Looks like this. So 1 to 1 because we need to make it neutral. This is copper to sulfate. Now, let's start looking at number 2, the molar masses. So, the molar mass of copper is 63 point, let's go ahead and take a look at our periodic table. And so for copper, it's 63.546 grams per mole. Sulfur, look that up. We now see it's going to be 32.066 grams per mole. And the oxygen should be 15.9994 grams per mole. And now, what about the copper 2 sulfate? So that's going to be equal to the 63.546 plus the 32.066 plus 4 times the 15.9994. And my units for all of this will end up being grams per mole. Okay, so when we calculate it out, this is the thousandths place, that's 10,000, so we're going to go to the thousandths place. So 63.546 plus 32.066 plus 4 times 15.9994. We get something like 159.610. We had to round up grams per mole. Okay, so now that we have all our molar masses, now we can start calculating the mass percents, the percent composition for copper 2 sulfate. Okay, so let's do the copper first. That's going to be, we have 1, so 63.546 grams per mole divided by 159.610 grams per mole times 100%. And that's going to be equal to 63.546 divided by 159.610 times 100. Okay. Hold on. 6, 59.610 times 100. And then I get 39.813%. So the copper is done. Now let's look at the sulfur. So for sulfur, percent sulfur, 32.066 grams per mole divided by, again, the 159.610 grams per mole times 100%. Okay, when we do that, we get 20.090%. Okay, and then finally, erase a few things. I'll give you some space here. We have the oxygen. Okay, so percent oxygen. Now, how many do I have in my formula? My formula here, I have 4 oxygens. So we're going to say 4 oxygens. Each oxygen has a molar mass of 15.9994 grams per mole. And then we're going to divide it by my whole molecule, which is 159.610 grams per mole times 100%. Okay, so 4 times 15.9994, okay, and then divided by 3, 4, 5, 6, okay, 159.610 multiplied by 100, we get 1, 2, 3, 4, 5, 6% oxygen, okay? Now, how do you check? Well, the best way to check your work is that since we're looking at each part in a whole, the sum of my percents should be equal to 100%. And this could be plus or minus. I think your book was saying 0.5%. Okay, so let's add it together. The 39.813 plus 20.090 plus the 40.0962. So the sum is equal to 99.9992%. This goes to the 3rd decimal place. 1, 2, 3 here. So 99.999%. Why do we get some small deviation? And that's going to be due to rounding errors. But essentially, we're done and we've completed calculating percent composition. So what we're going to do next, in the next lecture, is use percent composition in order to determine empirical formula and molecular formula.